Okay, today we're going to work on solving inequalities. Remember, an inequality is sort of like an equation, but instead of an equal sign, like that, you have, a less than sign or a greater than sign or a less than or equal to or a greater than or equal to sign. These are the different types of symbols that you'll typically see in an inequality. And it pretty much just means instead of something being equal to something, you're just saying something is less than or greater than that quantity. Okay, so let's just go right on in and look at how we can start to solve some of these inequalities. Let's say we have x plus 2 is greater than 5. Now, normally we see equal signs here, so that means this is equal to this. In this case, what I'm saying here in the equation is whatever x is, or whatever set of numbers x is, when I add 2 to it, it's going to always be greater than 5. Okay, so let's go ahead and solve for what x actually could be. We're going to do it the same way we do equations. We need to get x by itself, so we're going to simply subtract 2 from both sides of this inequality, and then we're going to get x by ourselves. So let's do that. On the left, we're going to have x, and then I'm going to subtract 2 from both sides. On the left, x, 2 minus 2 is 0, so it's going to go away. I'm going to keep the greater than sign is greater than 5 and minus 2. Here all I've done is subtract 2 from both sides. On the left it went away, the 2 went away because 2 minus 2 is 0, and on the right I have this. So that means that x is greater and 5 minus 2 is 3. Now notice that x is not equal to a number. X is a set of numbers. X, in this case, the values of x that satisfy this equation are all values of x greater than 3. So that means the numbers that satisfy this inequality are numbers like 4, 5, 6, 7, all the way up to infinity. Notice 3 is not included in this set because it's a greater than. X is greater than 3. It's not equal to 3 because we don't have a bar under here that says equal to. So these are the set of numbers that satisfy this original inequality. And you can show that on your number line. Remember from the very first video we talked about the number line. So here's a number line. Here's 0, 1, 2, 3, 4, 5, etc. and it goes off to infinity. Well, if x is greater than 3, I'm going to put an open circle here because we are not including 3, and so x is greater than 3 is simply going to be all the values. I can't seem to get this to write correctly. All the values out here off to positive infinity. So from 3 greater than. So that's how you graph that. Now in numbers it's 4, 5, 6, 7, 8, etc., etc., etc. But that's how you graph it. Okay? So that was a fairly simple inequality, and none of them are really hard. If you know how to solve equations, you're going to basically be able to solve these inequalities. And there'll be a few things along the way that we'll deal with. Let's say we have negative x, like this, minus 3 is less than or equal to 7. Let's just say. Okay. Now this is going to be just like an equation. I want to isolate x by itself. So how am I going to do that? First I'm going to get rid of this 3 and I'm going to move it over here. In order to do that I'm going to add 3 to both sides. So I'm going to be left with negative x less than or equal to 7 plus 3. On the left I've added 3 and the 3 went away. On the right I've got 7 plus 3 and this is equal to 10. So I'm going to have negative x is less than or equal to 10. Now that's pretty darn good, but I want x by itself. So in order to get x by itself, I need to divide by negative 1 because this is really a negative 1 times x, so I can divide by negative 1 and that'll get rid of the negatives, and I can divide by negative 1 here. Now here is the thing to keep in mind during this lesson. This is the most important thing. When you divide or multiply, see, adding or subtracting numbers across inequalities, no problem. No difference from equations. The only difference is when you add or subtract, when you multiply or divide negative numbers, you must flip the direction of the sign. It's just the way it works. Okay, you just need to memorize that. Do not forget to do that. If you don't do it, your answer is going to be completely wrong. So here I'm going to divide by negative 1. I'm going to divide by negative 1. I'm going to divide by negative 1. So I'm going to have x on the left. I'm going to have negative 10 on the right, because 10 divided by negative 1 is negative 10. But instead of the arrow going this way, I'm going to flip that arrow around and put it that way. Only then is the answer correct. X is less than or equal to negative 10. So on your number line, if this is negative 10, you know, the set of all numbers like that are going to be all these numbers like this. Just like that. And it's going to be including negative 10, so you're going to have that with a closed circle right there. I'm sorry. I've totally made a mistake here. Just forget about that. What you're going to have here is you're going to have a number line that looks like this, and you're going to have negative 10, and it's all numbers greater than negative 10, so it's going to be closed and it's going to be to the right. I apologize for that. It's going to look like that. So you put your number and it's going to be greater than, off to the right. And that's the answer. Okay. Okay, so the next kind of problem we're going to do is going to look a little bit simpler. And I'm going to go ahead and try to mix it up again. I wouldn't want you to get too accustomed to what I'm doing here. I'm going to go ahead and try to make it a little bit different and use a different color. So I've got, let's say, 2x. I don't really like the way that comes out. It doesn't show up as well. Let's say we have 2x minus 3 is less than or equal to 5. Okay. I want to get 2x by itself, so I'm going to move this 3 over here. So I'm going to add 3 to both sides. I'm going to be left with 2x is less than or equal to 5 plus 3. So carrying this down, 2x is less than or equal to 5 plus 3 is 8. Okay? And in order to get x by itself, I'm simply going to divide both sides by 2. So x less than or equal 8 divided by 2 is 4. I did not flip the order of this sign because I did not multiply or divide by a negative number. And on your number line, that's going to look like, if this is 4, 0 is over here and 4 is over here, then I'm going to have a closed circle because it's less than or equal to, and that's going to be all these numbers off to the left, less than or equal to 4. So we're talking, you know, 3, 2, 1, 0, negative 1, negative 2, negative 3, on to negative infinity. So notice for inequalities, by and large, your answer is not going to be a number. Your answer is going to be a set of numbers. And that's just simply because inequalities are equations that kind of involve sets of numbers. So let's say we have 2x plus 9 is less than or equal to x plus 8. Okay. First I want to move this x over here, so I'm going to subtract x from both sides. 2x minus x plus 9 less than or equal to, x minus x is 0, so I'm not going to write it, and I have an 8 there. 2x minus x is simply x. Plus 9, got to carry that forward, less than or equal to 8. Just like this. Now I'm going to move this 9 over here. I'm going to subtract a 9 from both sides. I'm going to do the opposite of this addition in order to do that. So x, and 9 minus 9 is 0, so I'm not even going to write it, less than or equal to 8 minus 9. Here I've subtracted 9 from both sides. So then x is less than or equal to 8 minus 9 is negative 1. Okay? And then if you were to graph that on a number line, if you had negative 1, that would be the set of numbers to the left, which is less than that, and a solid dot, which means less than or equal to. So pretty much all the tricks that you've learned, you know, when dealing with your equations are going to be applicable here. Okay, let's say you have something that looks like 3 per parentheses x minus 8 parentheses less than 5x plus 6. First thing I want to do, just like equations, I want to get rid of these parentheses. I want to distribute the 3 in like this. So 3 times x is simply 3x. 3 times negative 8 is negative 24. 8 times 3 is 24, and negative times positive gives me negative. Carry my less than sign. I'm just going to rewrite the right-hand side of the equation. 5x plus 6. Okay, now I'm going to go ahead and move this 24 over here, get the numbers on one side. So I'm going to add 24 to both sides. So I'm left with 3x on the left, minus 24 plus 24 gives me a 0, so I'm not even going to add it. I'm going to carry my sign down. 5x plus 6 plus 24, because remember I'm adding 24 to both sides. So I'm going to be left with 3x less than 5x, and then I just add these numbers, which is, 24 plus 6 is 30, just like that. And now I'm going to move my 5x over here, so I'm going to subtract 5x from both sides of the equation, because the opposite of this positive number is a negative, so I'm going to subtract. So I've got 3x minus 5x less than 30. Because on the right, 5x minus 5x is 0. So continuing, 3x minus 5x is negative 2x less than 30. Because the bigger number is negative, so it's going to be negative. 5 minus 3 is 2. You've got to carry the x's through. Okay? And then the final thing is, I'm just going to continue this right there. The final thing is, in order to get x by itself, I need to divide both sides by negative 2. Just like this. Okay? So on the left, these 2's are going to go away. Okay? Which leaves me with x. And then 30 divided by 2 is 15. And because I have divided both sides by this should be negative 2, by a negative number, I must flip the direction of this sign. So x is greater than 15. That is the answer. And of course, if you were to graph that, if this were 15, you'd have an open circle, and it would be all the numbers out here to the right, greater than 15, but not including 15. Okay. Okay, let's do one like this. Let's say we have x times 5x minus 5 greater than 5x squared plus 15. Just like that. First, let's distribute the x in. X times 5x is simply 5x squared, because x times x is x squared. The 5 just stays the same. Minus 5 times x is 5x. Greater than 5x squared plus 15. I just rewrite the right-hand side of the entire equation here. Notice I've got a 5x squared and a 5x squared. Those are going to go away. And it's the same reasoning as regular equations. It goes away because I can subtract 5x squared from both sides of this equation, and that means this one would go to 0 and then this one would go to 0, so they just drop out. So I'm left with negative 5x greater than 15. And in order to get x by itself, I've got to do the opposite of this multiplication, so I'm going to divide by negative 5, divide by negative 5, which means x is going to be less than negative 3.